All right, let's go ahead and take a look at the average rate of change. So first, I want to show you the geometric illustration to this formula before we look into this formula. So suppose we have a curve on the xy plane. Let's just say some curve like that. And this is our y equals f of x. And let's say we have a point here that is x1, and we have a point here, we're labeling it as x2. And we want to find the slope connecting these 2 points. So let's see if I can draw this correctly. If I draw a line connecting these 2 points, I have created a secant line. So the slope of this secant line is what we call the average rate of change. Well, now how do we find slope? Well, as you remember from algebra, slope is pretty much changing y over changing x. So we look at the change in the y value. So think of it as this is the rise and then run. So we create this triangle and find the change in the y value over the change in the x value. So that's what we have right here. Or you can think of it as this is the rise over run formula from algebra. So the way you're going to find that change is, so we know the first point was x1. That means this point right here is the function evaluated at x1. So that's f of x1. Then the y value of the second point right here would be f of x2. So that's what we have, f of x2 minus f of x1 divided by the change in the x direction. That's x2 minus x1. Now, later on in the future, we like to simplify the notation. So instead of calling x2, we're actually going to call this point just a little bit more than x1. So let's say x1 plus h, which means the second y coordinate, I can also write this as f of x1 plus h. And then we get to this formula right here. Now hold on to this thought until we get to the tangent line idea, because that's when the notation will be much simpler to use. We would rather use this one versus this one. So now that we have a little understanding of this formula, let's go ahead and try to do some examples. So here's our function, and we want to find the average rate of change within this interval. So let's go ahead and do that. So we know that the average rate of change is given by f of x2 minus f of x1 over x2 minus x1. You might have known this formula in a different form, but this is the one I'm going to use it here. You might also have known it as f of b minus f of a over b minus a. So this is also the same formula for average rate of change. Instead of x1, x2, we're using a and b. So it simplifies a little bit more. But let's use this one since that's the one I introduced previously. But feel free to use the one on the right if you feel comfortable. So let's go ahead and label our x1 and x2. The first coordinate will be the x1. The second one will be x2. So we need to find f of x1. So f of x1 would be f of 1. Plug in 1 into the function. Now in this notation, we're going to be using g instead of f. Just switch a little bit. So g of 1 is going to be 1 squared minus 2 times 1. So that's 1 minus 2. That is negative 1. And then g of x2, it's going to be g of 3. That is 3 squared minus 2 times 3. That would be 9 minus 6, which is 3. So we found our function values. Now let's simply plug this into our formula right here. So we're looking at g of x2 minus g of x1 divided by x2 minus x1. So in this problem, this is our g of x2. This is our g of x1, and x1 and x2 are these points right here. So let's substitute them. So we have 3 minus negative 1, because that's g of x1, over x2, that is 3 minus 1, which will give us 4 on top over 2 on the bottom, and that simplifies to 2. So the average rate of change, or the slope of the secant line on this interval, happens to be 2. All right, so let's go ahead and try another example. So let's say we want to use the function, so this is our example 2. F of x is equal to 1 over x, and we want to find the average rate of change on the interval 2 and some a. It could be any real number. We just want to try out with some arbitrary real number a. So we'll do the same thing. Again, if you want to try it out on your own, pause the video, work it out, and then come back, check again. Let's call this one x1, this one x2. We want to find f of x1. That's going to be f of 2. Plug in 2 into the function, we get 1 over 2. So that is our f of x1. Now for f of x2, we're finding f of some a. Again, we replace a where there is x in the function. This is simply 1 over a. And that doesn't simplify, so we leave it here. Now we're ready to find our average rate of change. So the average rate of change over this interval would be f of x2 minus f of x1 all over x2 minus x1, which would be f of a minus f of 2 all over a minus 2. And then we plug in what our function values are. For f of a, that is 1 over a, minus f of 2, that's 1 over 2, all over a minus 2. Now, you want to simplify this a little bit more because we have fractions right here. We want to combine that. So we're going to find the least common denominator to combine that. So the least common denominator for the two fractions on top is 2 times a. You need this and that. So now we multiply each fractions, what they're missing to obtain the common denominators. So I multiplied this with 2 over 2, this with a over a, and that gives me the following. So on top, I get 2 over 2a minus a over 2a all over a minus 2. And now that the top has same denominator, I can join them into a single fraction. That is 2 minus a over 2a all over a minus 2. And just continuing on with simplification. Now, because we have fraction over a fraction, you can write this as a fraction like that over 1. I can simply write that as 2 minus a over 2a times the reciprocal of the bottom. That's 1 over a minus 2. Now, a minus 2, if you realize, and 2 minus a, they're almost the same, except they differ by a negative sign. So if I were to cancel them, I must put a negative 1 somewhere to place that difference. So in reality, that's what I get by canceling them. I get a negative 1, either on top or bottom, and this gives me negative 1 over 2a as my final average rate of change for this problem. For this problem, we're going to find the average rate of change by using this given graph. So we have this graph of showing the total distance S traveled by a bicyclist after some t hours. So let's see what we're looking for. We want to estimate the bicyclist average speed, which is same idea as average rate of change. We know that the distance, so the average speed, it's the distance traveled divided by elapsed time. So pretty much the change over y, change of y over change of x, just like we saw earlier with those two examples. So we want to find the average speed over this interval, 0 and 1. Again, you can call 0 as your x1 and 1 is your x2. So over the interval 0 and 1, our average speed, it's going to be, let's call it average speed. It's going to be the change in distance over time. So that'd be s of 1 minus s of 0, because this is our x1, this is x2, over x2 minus x1, so that's 1 minus 0. So if you look at the graph, when the time is 1 hour, we're looking here, and our function happens to be right here. So that's 15. So we can say that s of 1 is 15. Now for s of 0, we're looking at when time is 0, 1 hour, and the function is right there. So that's also 0. All over 1 minus 0, well, that's just 1. So this happens to be 15. And we can say this is in miles per hour, so this will be miles per hour. So the average speed over this interval, 0 to 1, happens to be 15 miles per hour. Let's do the same thing for the next part, between 1 and 2.5 hours. So again, I will call 1 is my x1 and 2.5 is x2. So over that interval, we have, let's say, we're looking for the average speed, which is s of 2.5 minus s of 1 over 2.5 minus 1. So 2.5 is right here. So the height we're looking at is this one, and that is 20. So it's 20 minus s of 1. Well, we know what that is. That's right here. And we said that that's 15 all over 2.5 minus 1. That happens to be 1.5. So 20 minus 15, that gives us 5 over 1.5. And this is approximately 3.3 miles per hour. So that would be the average speed over that specific interval. And lastly, we want to look at this final interval, 2.5 and 3.5. So let's go ahead and do the same thing. So this is the x1, this is x2. So so the average speed is going to be s of 3.5 minus s of 2.5 all over the change in the x values. That's 3.5 minus 2.5. So at 3.5, we are assuming this is 3.5. The height is right up here, and that is 30. We can estimate it to be 30. So this is 30 minus 2.5. We said that that was right here, and from previously we said that's 20. That is 20, and then 3.5 minus 2.5, that's 1. So this will give us 10 miles per hour. So there you have different average speed over different interval. All right, so I hope this makes sense.